Hi, I'm Bob Dobkin. I'm the Vice President and Chief Technical Officer at Linear Technology. And I want to talk about what I think is one of the most exciting architectural changes in voltage regulators in 10 years. We have an entirely new architecture for voltage regulators. Most old voltage regulators take a reference and an amplifier and a divider resistor and amplify up the reference to get the output voltage that you need. The new architecture is in the LT3080. It's a current source that has a 0 TC current and a power voltage follower. So we feed the current through a resistor to ground that sets up a reference that goes into the voltage follower, and the output voltage is the same as the voltage on the resistor. The voltage follower is precision. It has offsets in the order of a millivolt. And the fact that we don't have a divider resistor means that the gain of the loop doesn't change with output voltage. So we can specify the output regulation in millivolts, and it stays in millivolts. It doesn't change as a percentage as the output goes up. So the LT3080 is a 1.1 amp regulator. It has a 1 mic cap on the input and output, one resistor to set the output. And some of the things you can do with this architecture are you take several devices and put them in parallel to get higher output current. You tie the set pins together, then the outputs are all within a millivolt, and a few milliohms of ballast resistance makes them current share. So you can take several of them on a board and spread the heat out so that you can make all surface mount power solutions. The LT3080 is extremely easy to use. Only takes a capacitor on the input and output and a resistor to set the output voltage. We brought out the collector power pins separately so that we could add a resistor in series with it so we can spread the heat even further. So for a surface mount solution, you can have part of the heat dissipated in the regulator and part of the heat dissipated in a resistor. This allows us to get higher power dissipation in an application without having to go to heat sinks. We can have an all surface mount solution and dissipate more power than a single device is capable of. For paralleling, you take two devices, tie the inputs together, the control pins together, and the set pins together, and that sets the output voltages equal. Then 20 milliohms, which is just a few tenths of an inch of copper clad board, acts as adequate ballast to make the current share. And I just show two here, but there's no reason you can't share current in 5 and 10 of them to get a much higher output current. Some people want to have the resistors internal because they'd like to put these devices down on a power plane. So people have asked us to provide a device with the ballast resistors internal. We've done that. We've modified the LT3080. They have a 25 milliohm ballast inside the device, and that's the LT3080-1. No external devices and no external traces are needed for ballasting. How well do these devices share current? Here I've got two devices on a board dissipating power. They're only about 2 inches apart, and I've taken a thermograph of the device looking at the temperature rise of each device. There's only about 4 degrees difference between the devices, and you can see here that separating them by about 2 inches gets the area in between them back down to the ambient temperature. So it doesn't take a lot of board space to take the devices and parallel them to get higher output current. As I mentioned earlier, the LT3080 is a very versatile device. Here's an application where we use it as a 2-terminal current source. We take the set resistor, the set current, and feed it through a resistor to generate 1 volt. That 1 volt is then impressed upon R1, and R1 sets the current through the whole device. So if I wanted to make a 100 milliamp 2-terminal current source, R1 would be a 10 ohm resistor. The frequency compensation, the input and output cap, is replaced by a single capacitor that goes from the input pin to the output pin. This puts the compensation capacitor within the feedback loop. So for voltage changes, current charging and discharging the capacitor doesn't affect the output current because it's actually inside the feedback loop. So I've talked a little bit about the LT3080, a new architecture for voltage regulators. It's applicable here in a linear regulator, but there's no reason that it couldn't be used in other regulator types. Thank you.